Now let's try to understand means what is data model. Basically, data model is a very important task of an analyst. Since we are learning means to become a data analyst, means what are the things which we should learn in terms of data model. Means earlier, like in the previous sessions, we have seen data preparation. So where we actually connect to different data sources, we take the data, maybe we can use a import connection or maybe a query mode connection, but that we import the data, we put it in our query editor. We do perform some of the quality check, some of the transformations, some cleaning of the data and creating queries or tables. So that kind of things which we do as a part of our data preparation. That is the initial step. Second step is data model. Since we do have different queries, we need to understand means why this data model is required and what is the role of it. So let's try to see what are its benefits. So the very first thing is the data exploration is faster. Means if you have a data model where different tables are joined to each other, then we should be able to understand means which are the tables which are connected to each other, how they are connected, if there are any hierarchies in the data. So that kind of things is faster with the model. Aggregations are simpler to build. Means what are the aggregations like? Means if you are doing some summarization of the data, average, minimum, maximum, that kind of things, if you are going to do, it is going to be helpful, or it is going to be simpler to build in data model. Reports are more accurate. That is what means when we have proper joins between different tables as per the business requirement, then we can say that reports can become more accurate. Writing reports takes less time as well, means since everything will be defined in a specific way in a data model, it will be going to helpful for in the report creation as well. Reports are easier to maintain in the future as well. So data model, once we have a data model, then because there will be some relationship, some strategy defined between different tables, it will be helpful for our reports to maintain as well. And what are the different rules for designing data model? So very first is we should aim for simpler models. It should not be very complicated. There will be some schema models we can use. However, it should be very simpler. It should not be very complicated, like there are hundreds of tables and they are joined each other, and it's if that will going to be very hard to work and hard to maintain as well. So that should not happen. That's why we should able to see that means whatever the things which we can do, we should minimize number of tables. We should try to maintain the joins clear as much as possible. That things we can do. So there are primary key, foreign key, and that we need to understand, because every table will have one unique key, and that can be referred to other table which is a foreign key. So that we need to understand. We need to see multiple data sources like Excel, SQL database, or any other data sources like online data source or other things. So that we can use, and based on that we can prepare this data model. Now there are different schema models, like whenever we are developing or whenever we are designing any data model, we should be able to understand a particular structure, like what should be the structure. So in the data modeling or data warehouse area, you can say there are different schemas which has developed by like few people earlier, and that is a normal like standard culture in data warehousing while designing any. So it is not just specific to any database, but it's overall for all the databases like SQL Server or Oracle databases or any other relational databases. There are some schema models has been designed, and that schema model gives the proper data, so that we must follow. So generally star schema is a very popular star schema which is being used, and in our course as well we are going to use the same in the practical examples as well. So what is a star schema? So in star schema, each table within your data set is defined as a dimension or fact table. So there are two things, dimension and fact table. We are going to see what is dimension table and fact table. Now, when dimension tables are like, you can say data which is going to reference the fact table or transactional data. So transactional data will be having a daily transactional value like price, amount, that kind of things will be stored in the fact table. Other fields like for name, address, like pin code or maybe street address or something like that, it will be stored in the dimension table. So that will be uh, joined with the like this dimension table will be joined with the fact table. So we can say this is the first fact table. So fact table will be at the center, dimension table will be the like um, on around it. So we can say how this is joined. So these are the different tables. Like we can say these are the this is the common star schema structure where fact table will be a transactional and all their dimension tables will be around it, which is going to join, and this is how it is being used. So we are also going to use this, and there are like other schema models as well, but that we are not going to see. But this is also very effective and simple as well for everyone to understand, so that we are going to see. Now fact table. So fact table contains observational or event data values. So that's what I said. Whatever the transactions or whatever the uh, like daily transactions happening in a day, all the data will be stored in the fact table. So that is what it is stored. Like you can say sales orders, product counts, prices, transactional dates and times and quantities. So these are the stored in the fact table. It can contain repeating values as well, and it is in larger in size. So sales is one table where you can say this is ID, date, product ID, status, but there is the amount field which is transactions. So in a day, if there are 100 transactions happening, so there will be multiple rows here for each of for one date only. So date will be repeating here, ID will be increasing, it will be unique, and its product ID may be same or different as well. uh, Status paid or unpaid, whatever it is, but amount will be like this. So maybe $100, $30, $60, or maybe less than that as well, or any amount, whatever it is, the product size is, the product price is. So that will be stored in this amount field, and this can contain hundreds of repeating data, and just only this amount field will be changing. So this is the fact table. Now the dimension table is another table where which contains the details about the data in fact table. So what are the sales transactions is happening? So maybe for a particular product, these are the transactions happening. Like there are hundreds of transactions happening that which are stored in fact table. So, but for which product? So that product will product information will be in another table that will be stored called as a dimension table. Now you can say products, location, employees, order types, that kind of information which will be there, and this contains unique values. It will not be repeating because um, let's say a product will be unique, one product, one ID for it, and it will be attached to the fact table or the transitional table. So that is how it is. That's why it is unique. It will be a smaller in size, it will not be a very bigger in size, because it is having unique values. And you can see this employee. So in employee, you can see employee ID, employee name, product group, state and category. So these are the information which are stored there in particular employee table, and that's how it is. It will not contain any, like you can say employee salary column will not be there. It will be in a fact table. So it may be called some different name, but that will be in a another table which is called as fact table. So that's how it is. Now, when we work with tables, because data model consists of different tables only, so it doesn't have any other things which is like apart from table, there will be nothing like that. But table is important, and we are going to work with the tables. So we should be able to. The very first basic thing is whatever we are designing, it should be simple, because whenever it is a simple, it should be it makes things easy and simple to navigate, because of column and table properties that are specific and user friendly. Then we can have a merged or appended tables. That's what means we have seen in data preparation, that we have combined like two tables within a one. So out of four tables, we have just kept two tables. So that kind of things which we have used. So that kind of thing, merging or appending queries we can do, and that will make the column tables less smaller, and it will simplify our data model. Relationship, we need to maintain good quality relationship between tables, which makes sense, and which makes sense, that means it should be a business specific, it should be as per business need. So that's what we should able to understand. Now let's try to see what is comparing data model and build relationship between tables. So this is how it is. Basically, in our Power BI as well, we have seen means the two tables like can be joined on a unique. So this is sales table and this is order table. So you can see this particular ID, product ID is joined with this product ID. So that kind of things which we can see. And in Power BI, this is how it is, like this first table and second table. All the columns will be specified here, and we can select which columns we wanted to join and all those things that can be possible to specify. Its properties, column table and column properties. So how we can configure, so whatever the let's say this is a date properties, we have a data type, we can specify data type, its format as well we can specify. And there are different formats as well. Based on the formats which we wanted to do, we can select it from here. Create a date table. So based on this order date or ship date, we can create another date table, which can be used to join different dimension tables, because that will going to help us to create visual. So for that, we can create a common date table. So it will just hold the dates like months, quarter, like date, days or weeks. That kind of information can be stored only specific date table, because that we is going to help to build relationship. So source data, DAX, and Power Query. So these are the three ways to create tables, and we will see practically. DAX is another like advanced feature which we can use, and Power Query is we have use in Power Query editor, how we can create a date. So based on month, we have created some date column. So that kind of things which we can do. Source data is one thing where from wherever we are creating, getting data, at the database end only, there will be some date column. So that can be also possible. So sometimes what does this database developers or the DBS, they will design their tables at the database end. They can have the uh, calendar tables there only. So that can also possible. If it is not possible in the database, then we can have these two features, which are DAX and Power Query. We will see DAX as well, how to create it in the coming sessions. Now, source data is something which is we are going to connect, and based on that, we have as in source data means we can have their own date tables, and we can just like take those particular date tables and identify company holidays, separate calendar and fiscal year, identify weekends versus weekdays. So whenever any date table comes, it's all because of the with related to the financial years. So that is also we need to identify. Now DAX is the one thing which is we are going to see. So this is just some syntax. I will show you practically how we can create. So these are the calendar or calendar functions which are inbuilt. We can just give like this. You can see this is a function which is says create a date calendar starting from 2011 31st May to 2022 31st December. So this type of calendar, like for 10 years, we can create the date calendar table, and which will be created like this. Or if there is this features also we can use to extract the year. So this is how we can do. So we can extract particular month number, week number, day of the week. So these are things which we are going to see practically about this. And this is how it looks when we extract month number, week number, or day of the week. Now, Power Query is what we have seen already. Means whenever we are connecting, we are using that creating a table, like use yum language, which is we have already seen the development language that is used to build queries in Power BI to define common date table. Then we can see how we can create, like we can create a new query in this blank query, and then we can write see this list or dates. So this is some code we can write. There will be ready-made code as well available. We can just google it and we can try to find the source code, what how to create a date. So we don't need to worry about that, we need to write some code. It is readily available and that we can use. And this is how it creates, like you can see in Power Query with this M language. And it is, then we need to convert it to table. I will take this as an example as well when we go through some practical examples. This is how we can create it, and it shows all these things. And there is a final step when we create it, mark as a date table. So when we do this mark as date table, so that it will be identified to everyone that this is the date table which we can use everywhere. Now, the next steps are building visualizations and other things that we are going to see in the coming sessions. Right now, we just need to understand dimension tables, fact tables, the star schema, and how we can join. So that we are going to see practically in the next session. Do you have any questions? Whatever we have covered till now?
I think we have covered this thing before also. So I have bit knowledge about it.
Yeah, that's what means. Initially in analytics session, we have covered all these things as well, but earlier,
Exactly.
yeah, now also I just covered this briefly. So yeah. Okay, I think we are going to see practically in the next session. For my YouTube audiences, if you have any questions or any doubts related to this course or anything related to this Power BI, let me know in comment section. And if you like my video, then please like it and share it with others as well.